DeepSeek just blew up on GitHub, and for good reason. They've dropped a new open-source AI that can read massive documents and shrink 1,000 words into just 100, basically turning text into mini visual snapshots. Meanwhile, ShengShu launched a new video model to challenge Google's V3. It lets you blend faces, props, and backgrounds into full cinematic clips, all in seconds. Google's latest AI can actually see cancer mutations by turning DNA data into images. And Kohler? They've built a smart toilet that literally analyzes what you flush. Yep, the first AI that truly knows your data. From your, well, data. Let's start with DeepSeek OCR, because this one set the internet on fire. The open-source model went live just yesterday, and by morning, it had already racked up over 4,000 GitHub stars. The promise is bold. Take a 1,000-word article, compress it into roughly 100 visual tokens, and keep about 97% of the information. That's a total flip from the usual token-hungry text processing. Instead of feeding endless text into a tokenizer and paying the token tax, DeepSeek converts text into images, runs them through a vision encoder, and hands the language model a compact visual stream. And the speed? Wild. A single NVIDIA A100 can churn through roughly 200,000 pages per day. That's the kind of throughput data teams dream about for building pre-training sets, RAG databases, or compliance archives. The model's available right now on Hugging Face and GitHub under DeepSeek AI/DeepSeek OCR, complete with runnable GPU code, PDF helpers, and VLM acceleration tips. It's built with around 3 billion parameters, split between a 380 million parameter encoder that creates the visual tokens, and a mixture of experts text generator that activates about 570 million parameters at a time. Sparse activation keeps the compute lean without killing performance. Benchmarks? They back it up. On OmniDoc Bench, DeepSeek OCR beats Google's OCR 2.0, which needs around 256 tokens per page. DeepSeek does it in roughly 100. Compared to MinerU 2.0, which often goes over 6,000 tokens per dense page, DeepSeek stays under 800. That's a token reduction of 61% compared to Google and 87% compared to MinerU. And on Fox Bench, focused on complex PDFs, DeepSeek again delivers great news for teams dealing with math equations, diagrams, and chaotic layouts. The dataset behind it? Massive. Around 30 million PDF pages across 100 languages, including 25 million in English and Chinese, plus millions of synthetic diagrams, chemical formulas, and geometric figures. The output options are flexible too. Keep formatting, extract plain text, or get image descriptions. That means you can plug it into existing workflows without breaking a thing. Even Andrei Karpathy chimed in, calling it a solid OCR model, noting how it cleverly merges computer vision with language. His take, letting large models see text instead of read it, simplifies everything. No Unicode weirdness, no byte-level chaos, fewer security headaches. Now, not everyone's buying DeepSeek's cost claims. Some US researchers are questioning earlier benchmarks. But what's undeniable is the token efficiency. Cutting tokens by 7 to 20 times and processing 200,000 pages daily. That's not hype. That's a real-world win. ShengShu's VidU Q2 just turned video generation from a gamble into precision control. Upload up to 7 reference images, faces, props, environments, add a text prompt, and it stitches them into a seamless clip while keeping every element consistent from frame to frame. It even handles transitions between just a first and last frame, giving editors narrative control without endless prompting. And there's an API from day one so studios can plug it into production workflows. No need to babysit a web interface. What's truly impressive is its real-world reliability. In one test, they recreated a factory scene, a battery module on a conveyor, an industrial robot scanning it, and a live production display in Chinese text. VidU Q2 nailed the shot. Clean text, stable motion, accurate logos. Meanwhile, Video 3.1 struggled with the Chinese characters, and Sora 2 even swapped the logo with Nissan. For brands and regional campaigns, that kind of precision matters. In another demo, they staged a boardroom argument. A Chinese executive angrily asks, "The battery caught fire. Are you kidding me?" The American CEO replies, "Not me, it's them." VidU Q2 pulled it off. Perfect facial expression references, synced lips in 2 languages. Reviewers said the voice tone wasn't quite as emotional as Video 3.1, but the multi-character consistency and bilingual lip sync? Spot on. Basically, the AI just executed a bilingual argument. Somewhere, Duolingo's sweating. A little context. ShengShu launched in March 2023 from China's AI Industry Research Institute, rolled out VidU 1.0 last April, and now claims 30 million users across 200 countries, with 400 million videos created. Today's Q2 model generates 5 to 8 second 1080p clips from text or images in English or Chinese. And it's built for creators who want control, not just shock value. Add the API, faster processing, and cheaper pricing than Sora 2 or VidU 3.1, and you've got a serious contender for commercial video production. Now, from movie making to something far more serious, cancer detection. Google Research and UC Santa Cruz just unveiled DeepSeek's, an AI that reads cancer genomes like deep variant on steroids. It identifies even the smallest DNA mutations, tiny insertions, deletions, or single nucleotide changes that can completely alter how a tumor behaves. Here's the genius part. It doesn't just read DNA, it visualizes it. DeepSeek's stacks genetic sequences like pixels and lets a convolutional neural network tell real mutations from noise. It works across all major sequencing platforms, Illumina, PacBio, Oxford Nanopore, with no retraining needed. Trained on a dataset called CAS, covering tumor normal pairs across all 3 platforms, it scored 90% F1 on Illumina Indels. The next best tool barely hit 80% and over 80% on PacBio. Others struggled to hit 50%. It even discovered 10 previously undetected variants in pediatric leukemia and identified known mutation drivers in glioblastoma. For labs, that means one model, multiple platforms, fewer errors, and faster analysis. Basically, for the first time ever, your genome might actually want you to draw me a picture. Thanks for watching, and I'll see you in the next video.